Arithmetic series. Do not forget to subscribe, and if you have any question about arithmetic sequences, you should watch this video before continuing. We know when the terms of a sequence are added together, the sum is referred to as a series. Therefore, the sum of the terms of an arithmetic sequence is called an arithmetic series. For example, this sequence is an arithmetic sequence, and the sum of the terms is an arithmetic series. An arithmetic series is the sum of the terms of an arithmetic sequence. When a series has only a few terms, adding the individual terms is not a difficult task. However, if a series has many terms, it would take too long to add all of those terms. It will be helpful to find a rule or formula for evaluating arithmetic series. Pay attention in the following arithmetic sequence. To develop a formula for the sum of any arithmetic series, consider the arithmetic series. The series has 5 terms, so we write S sub 5. If we reverse the order of the terms in the equation, the value of the sum is the same, and it looks like this. Now we add each pair of numbers together vertically, term by term. S sub 5 plus S sub 5 is 2 times S sub 5. We should notice that the sum of each pair is always the same. We get the same result if we multiply one of these pairs by the number of pairs. Finally, we must divide both sides by 2 to find the sum of these 5 terms. Now let's see this formula. We can say that 22 is the sum of the first term with the 5th term. The result is multiplied by 5 because the number of the pairs is 5. At last, we divided by 2 because we want the sum of 5 terms and not 10 terms. It's always true. In any arithmetic series, the sum of the terms is given by adding the first and last term, divide by 2, and then multiply by the number of the terms. Don't forget, we always can use the sigma notation. Find the sum of arithmetic series. We should check if this series is arithmetic. And we can see that this is an arithmetic series. 17 minus 11 is 6. 11 minus 5 is 6. The common difference is 6. We also know the first and the last terms. But we need to find how many terms there are in this series. And to do that, we need to find the value of n. To find n, we put the known values into the formula for an arithmetic sequence, and solve for n. Since we know this series has 8 terms, we can substitute the known values into the formula for the sum of an arithmetic series. Perform the calculations. The sum is 208. Oscar decides that he will save an extra $2 each week. He saves $6 the first week, $8 in the second week, and so on in arithmetic progression. How much will he have saved over the first 13 weeks? How long will it take him to save $300? Start by writing down what you know and then what you need to find out. We know this sequence has 13 terms. The first term is 6 and the common difference is 2. The sum of the amount saved in the first 13 weeks is denoted by S sub 13. First of all, we need to find the last term. So we substitute the known values into the general term formula for an arithmetic sequence. The last term is 30. We can substitute the known values into the formula for the sum of an arithmetic series. Oscar will save $234 over the first 13 weeks. How long will it take him to save $300? This time, we want to find the number of terms in the sequence when the sum of the sequence is 300. We substitute the values we know into the general term formula for an arithmetic sequence. Now we substitute the known values into the formula for the sum of an arithmetic series. Rearrange the equation to solve for n. This is a quadratic equation. Solve using the method you think is best. Remember that n is a number of weeks, so it must be a positive integer. Therefore, the solution of minus 20 is not possible. Oscar will take 15 weeks to save $300.